Alright guys, I am back again this week to teach you 12.4, which is simplifying our rational expressions. Alright, if you guys remember, our focus for chapter 12 is all on what are called again our rational expressions. As you can see, what I have written here is that rational expressions are fractions that can be written as ratios, which again are fractions. So again, all of our problems that we've been focusing on have been fractional problems. If you guys remember, what that looks like graphically is something like this. So we had our graph with our asymptotes. Remember, those are the places where our graph does not exist. And then we just sketched in those branches here. All right, some vocab that you guys want to watch out for is going to be this term excluded value. It is going to be abbreviated with this EV, so that is your excluded value. And what your excluded value is, it is a number that makes the expression undefined. So what we're looking for is going to be where does this problem not exist, and that happens when our denominator is set equal to 0. So I'll show you what that looks like in terms of the problems that we will be solving. All right, so here is an example of a rational problem. We have the fraction 2 over x minus 3. As I just said earlier, our excluded value is when our denominator is 0. So like we did with our asymptotes, this is essentially an asymptote, we're going to just set that equal to 0. X minus 3 is equal to 0. So in this case, x is equal to 3. And so what that means is that 3 is our excluded value, our EV or excluded value, and then this is just going to represent the value where the graph does not exist. So you guys are going to be seeing problems that are going to ask you to find the excluded value. And just like we did above, you just want to make sure that your denominator is going to be equal to 0. All right, so here are 3 problems that we are going to find the excluded value for. Remember, if we're looking for the excluded value, we want to make sure that we are setting these denominators equal to 0. So go ahead and try that and then follow along if you are unsure. So here are your excluded values. So your first one, again, you're setting that denominator equal to 0. The value of x then would be 0, or again, I should say your excluded value is 0. For your second one here, excluded value was -7. And then for this one, I actually factored it was a difference of squares. But your excluded values, you would have 2 here. It would have been +3 and then -3. And again, the vocab that you would use is excluded value or that phrase EV. And you can just abbreviate it as so. All right, guys, and so the last focus then of this lesson is going to be simplifying our terms as much as possible. So just like any fraction, we know that we always want to simplify. We want to do the same thing here. So what I have written down for you guys is that a fraction or a rational expression in simplest form is going to happen when your numerator and denominator have no factors in common. So for example, just like we have with fractions, let's say you had the fraction 10 over 20. We know that we would simplify that down to 1/2. We're going to be looking to do the same thing with our rational expressions, and I'm going to go ahead and show you guys a couple of examples to do that. All right, so in our first example that we're going to take a look is actually something that we've been looking at. I've commented on some of your homework assignments. Even though there is an r here, think of this as that fraction. That 10 over 60 can be simplified down to 1 over 6, and then that r would remain on top. You could also write that as r over 6. Another common fraction that we can simplify might be something like this. Let's say we have r over 2r. In this case here, you have r's both on the top and the bottom. Those could actually cancel out, and you would be left with 1 over 2. So just some things to watch out for as you are simplifying. However, the good part is coming right now. What I'm going to tell you is to be successful at simplifying rational expressions, you need your factoring skills. And so for some of these problems, you are going to have to break them down. And to break them down, we are going to be looking to factor. All right, so here's our first problem. We have 6m to the third minus 12m squared all over 18m squared. And I'm going to tell you guys this, factor everything. That is actually going to be your first step, is look to factor everything. All right, if you guys take a look at the top here, I can actually factor out a 6 here from both terms. So this has a 6 and this has a 12, so they have a common factor of 6. And then notice here, this one has 3 m's and this one has 2 m's, so they actually both have 2 m's in common, so that is my common factor. What that would leave me with then in parentheses is going to be an m minus 2. And then I'm going to go ahead and keep that 18m on the bottom. Just like we saw here, notice how we simplified that fraction. You're actually going to be doing the same thing here. If you guys were to cover up this part here, focus on, again, just this fraction part in the front. So this part right here. Look to simplify that. So again, think of that as your fraction. In this case, we know that 6 and 18 would simplify down to 1 over 3. So I'll rewrite that here, 1 over 3. Look at your m's also. I have 2 m's here and 1 m here. So this would simplify down to just 1 m on top. Because again, we've got m and m over m. That cancels, and that will leave us 1 on the top. So we're going to leave the m on the top. And then that m minus 2 is still on top, is going to remain on the top. So final answer, we can rewrite this as m minus 2 all over 3. Now, some of you guys are going to multiply this back, and you do not need to. Leave everything in factored form. Leave it, so this would be final answer here. All right, this concept is a little bit tricky because there are a lot of steps. You have to factor, you have to simplify. So let's go ahead and we'll try another one together. All right, so again, same thing. Look to factor first. What can we break down? On the top, 8x does not have any other terms to it, so we're going to just keep that as 8x. But on the bottom, we can simplify this expression down, so factor out that common term. Notice your numbers 8 and 16 both have 8 in common. X to the third and x to the second, they both have at least 2 x's, so x squared. And then figure out what goes inside that parentheses. So then we know that we would be left with an x here, and then a plus 2 here. All right, just like we did on our problem above, remember you can think of this as a fraction, so look to simplify that. This was a fraction, 8 over 8 would cancel. On the top I have 1x, on the bottom I have 2 x's, so we can cancel out one of those x's. So what that's going to leave me with is an x on the bottom. Notice that x plus 2 is on the bottom as well. And then what's left on the top is just that invisible 1. So please note that there is a 1 there, and make sure that you are putting that there instead of bringing all this to the top. All right, so that's your example there. All right, here is our next problem to simplify. What you'll notice here is that you have 2 quadratics. And at this point, we are pro at working at quadratics. So like I said earlier, what you want to do is factor everything. So factor these 2 quadratics here. All right, so again, for those who don't remember factoring, remember that's when we did our x method. We put the product of a and c here, so -10, and then b down here. Remember, we're looking for what 2 numbers multiply to give us -10. So I would say 5 and 2 that are also going to add to that -3, and then you're going to fill in those signs. So x minus 5 is a factor, and then x plus 2. For some of these problems, though, you guys will probably be able to factor them in your head quickly as well. For example, here, this would become x plus 4, and then x plus 2. All right, just like before, we are going to simplify, and we are going to look to cross out or cancel out terms that are the same. Now, here, you can cancel out binomials that are the same. So the binomial has to be exactly the same to cancel it out. All right, so again, just like I stated to you guys, binomials need to be exactly the same to cancel out. So for example here, if you notice you have x plus 2 and x plus 2, that is going to cancel out. You cannot say, okay, this has an x and this has an x, I'm going to cancel it. The whole term has to be the same. So not just the letter, but again, the entire term. And so that's why in this case, only the x plus 2 and x plus 2 are going to cancel. What that will leave you then with in simplified term is going to be x minus 5 over x plus 4. And that will be your final answer there. Let's go ahead and take a look at one last example together then. Same thing, we're looking to simplify our expression. Notice that with this problem, and you'll see this in the homework as well, it's going to ask you to state any excluded values. And I'll show you how we do that in terms of a problem. We did see that earlier in our example. So we'll go ahead and put all those skills together. All right, so just like I told you before, we do want to factor everything. Watch out right here. Think about that descending order. Like we know when we solve quadratics, we do want them in descending order. So I'm going to go ahead and actually rewrite this problem. All right, so let's go ahead and start solving this. So first step, like I said, is going to be factor everything. So step 1, factor everything. All right, so I went ahead and factored our top, and then I also factored out the negative here. So again, just like we saw in chapter 9, if there is that leading negative coefficient, you do want to pull it out. All right, now the next thing I actually want to point out to you guys is notice when I factored out that negative, hopefully you guys remember what this is. This is difference of squares. So you can break that up a little bit more. So again, when I say factor everything, I mean factor everything. So think about those different rules. So again, factors on top were x minus 3 and x minus 4. On bottom, again, we factored out that negative, so keep it there. If you guys remember difference of squares, that's when we have our square root of x squared, which is x, square root of 16, which is 4. And then remember, they're going to be opposite in sign, so plus and minus. All right, here is where our next step is going to come into play, though. And that's where this is that find the excluded values. So step 2 is find excluded values. And if you guys remember from earlier in this lesson, excluded values is where our problem does not exist. So it's when we set our denominator equal to 0. And so you're actually going to do it in this step here. So we want the excluded values of the original problem, not of the simplified answer. So of the original. So do it in step 2. So we're going to make sure that our denominator is set equal to 0. So we're going to take our factors here, and we are going to set them equal to 0. So we would have that x plus 4 is equal to 0. So x equals negative 4. And then our x minus 4 is equal to 0. So x is equal to 4. And so those are the excluded values of the problem. Notice that I didn't do anything with this negative here because there's no variable on it. There's nothing to solve for. So again, you're just going to be solving for where x is. So here we can already say that excluded values are going to be 4 and then negative 4. All right, so we already solved part of our problem. Now, the last thing then is going to be to simplify. All right, and then remember, like I said, when you are simplifying binomials, they have to be exactly the same to cancel out. All right, you'll notice that we have 2x minus 4s here so that we can cancel those out. So this and this cancel. And then what that is going to leave us with then is x minus 3 on top. Keep that negative sign there, and then x plus 4. And then this is our simplified answer. So we have two parts to this answer. So again, excluded values right here, and then also simplified answer right here. All right, guys, here is one final example. If you want to try it, if you want to follow along and make sure that that makes sense. If not, feel free to fast forward to the end of the video and then start the homework as well. But if you are going to try it, I will remind you guys of our 3 steps. Remember, on these problems, you are looking to factor everything. So on your numerator and in your denominator, pull out whatever common factor there is or factor your quadratic. Remember, find the excluded values of the original problem, not the simplified one, and then go ahead and cancel out any terms you can. So I'll go ahead and fast forward this, but you guys can see my steps also, and you guys can see how you are doing. All right, guys, so if you're following along, this would be your final answer. So remember, there's two parts to this answer. Excluded values here were 4 and -2. And then final simplified answer was 3 over x plus 2. So just a couple last minute things that I'm going to tell you guys to watch out for. Notice in that final simplifying here, I also simplified the numbers, not just the binomial term in the parentheses. So that 6 over 2 can simplify to 3. And then notice here when I simplified this denominator, I factored out a 2, similar to how I factored out a negative earlier. You can do the same thing. You still want to break down that quadratic that you have here though, and that's what I did, so watch for that. But again, try the homework, see how that is, and then let me know if you guys have any questions. All right, guys, that concludes this lesson. As always, make sure to email me if you guys have any questions, and then make sure to tune in next week for our final lessons. We'll have one more special guest, so you'll have to stop by to see who that is. All right, guys, have a good weekend, and I will see you later. All right, bye.